Now, I will take this proud privilege and opportunity to introduce our keynote speaker for the valedictory session. For the valedictory session, we have Professor Dr. Ajay Kumar, our keynote speaker. Dr. Kumar is Director of Interdisciplinary Engineering College in India. Dr. Kumar has obtained his PhD in Mechanical Engineering from NIT Kurukshetra. He has a rich experience of over 22 years in teaching undergraduate and postgraduate engineering students. Dr. Kumar has published more than 25 research papers in SCI and Scopus Index journals. Sir, I will be happy to have you as our keynote speaker of ICON MES 21 in valedictory session. And we are very much glad to have you with us. We request you kindly accept the request to speak and enlighten our audiences with your valuable talk.
Good evening to you all. I am Dr. Ajay Kumar, Director of Interdisciplinary Engineering College, Ghaziabad, NCR. And before going to start my presentations, I would like to thank the President of SRD, Dr. R.C. Singh, Vice President, Dr. Rajendra Kumar, Rohit Khokar, for giving me the opportunity to speak in the 6th International Conference on Management, Engineering, Science, Social Science and Humanities. So, sir, thank you very much. So, for describing the topic, role of multidisciplinary research in the engineering field, I am just recollecting the, please turn the slide. So there is a story. There is a story of American poet John Godfrey Saxe. There were the 6 blind men. They were describing the elephant, and they were describing the elephant in different ways. And one blind man, he was describing the elephant, and he was looking its tail. He was saying it's a rope, and one is saying he was touching the middle part. He was saying it's a tree. So there were six blind men. They were describing the elephant in different ways. In the same way, if I explain the interdisciplinary research, there is a story and there is a theme behind it, because if I belong to the mechanical engineering department, so not only one, I'm individually in isolation can create the good product, novel product. So I need the contributions from others, from other areas like civil engineering department, like physics, like chemistry, like computer science. So here I have to speak on the interdisciplinary research that integrates information, data, techniques, tools, perspective, concepts, and the theories from 2 or more disciplines or bodies of specialized knowledge to advance fundamental understanding or to solve the problems. And if we are solving the problems, we have to keep in mind whatever we are creating. We have to create and we have to identify the local needs, national needs, international needs, and we have to create the good, and we have to create and give the society. Please turn the slides. If I take one more point in the interdisciplinary research, so one more point just describing at this particular points to increase innovation and technology developments in interdisciplinary fields, and not only one area you have to cover many areas to establish partnership with relevant industries. Not only you have to take the advantages from the different departments, but you have to involve the relevant industries and research organizations in areas of mutual interest. So definitely you can create good one for the society. Please turn this slide. So these are the different definitions of the interdisciplinary research. So I am coming to the next part. Please turn the slide. All the tools which we are using in the interdisciplinary research, definitely not only one area which I have already stated. There are so many areas where we are using IoT and we are using the different optimization tools. And now we are creating the smart grid. We need information technology, communication technology, electrical, mechanical engineering. and in defense, because we are creating different tools for the army men. So definitely we have to take the advantage from the different areas. So that part is there. So these are the different basic definitions. And here I have just taken the one examples, because if you say that is the collaborations, ensure the whole will be greater than the sum of its parts. Like if you add 1 plus 1, it comes 2. If you add 1 plus 0, it comes 1. So definitely if you contribute, if you involve others areas, researchers, so definitely some good output will come, which will be useful for the society, for the other researchers. So that part is there. And if I take the because if I talk about the interdisciplinary research, so I have taken the data from the IITs. So they have developed the school of interdisciplinary research at IIT Delhi, and they have included not only engineering, they have included the humanities, management, and the science. Not only these departments they have included, but they have collaborated with the JNUs or AMs, because not only in one area they are working in different areas, and definitely they are giving good output and good product to the society. I've taken the examples, and I'll quote these examples in the coming slides. And one more, actually, the data I have taken from the IIT Jodhpur, because they have specifically created different schools on the applications of IoT and its applications, and created many things for the researchers. And they are giving product and the services to the different industries like manufacturing, energy, mobility, healthcare, infrastructure, logistics, living, and agriculture. These are the different areas where we can apply the IoT, and IoT has different fields, but these are areas belong to the different concern, maybe the civil, maybe the mechanical, or maybe the different agriculture fields. That part which we can taken the benefits from the IoT and its applications. Not only they have created the schools on IoT and applications, but they have developed and created one more schools, that is the digital humanities, and they are covering different fields. They have mentioned in the particular slides. They are covering, and they have created one more system on robotics and mobility system, and included and contributed in different ways. So these are the different examples I have just quoted, and the research which they are taking by creating these schools. And not only this, quantum information computation they have mentioned, and they have developed the one ecosystems where they are giving to this society to develop the smart healthcare system, and they are covering different areas which I have mentioned in the slides. And they have covered and created the space science and technology schools at IIT Jodhpur. So that part I'm not going to cover, because I've taken the example, and I've taken one more data from the MIT USA. They have developed the one computational science and engineering research and education system, where they are bridging the gap across the department, bridging the research in the College of Computing and Computational Research in the School of Engineering Science, Architecture, and Planning and Management in a highly interdisciplinary environment. It means not only in India, but abroad and in different abroad university, in foreign universities like MIT USA. If you open their website, and you'll finding number of products they are developing every year by contributing, by helping with each others, and finally they are giving these product to the society. This is the overall aim, and finally we have to create the novel product which will be useful for the researcher as well as the society. So that part is there, and they have created the ecosystem, the mechanism to take help from the artificial intelligence, human AI interaction collaborations, AI for advances in optimizations, AI and advanced cyber structure, AI in computer and network system, AI in dynamic systems, and these are the different areas where they have just created taken the help from artificial intelligence. Now I am coming to that part which I have done in my research work. I have developed the 32 fluxes. Actually, I've developed the fluxes for submerged arc welding. Welding is a joining process in which we have taken two pieces together and done the welding. But submerged arc welding is different welding process in which I've covered the welded process by the flux. If you are saying the flux, it means flux development not only done in one part. It requires the number of stages. The first one is the design part, and the another one is the basically the development parts, and the next part is the testing part. If I talk about the design parts, so I have taken the help I would use the tool of RSM, response surface methodology, and response surface using the response surface methodology. I have just designed the experiments, and on the basis of designing the experiments, I have mixed the quantity because I have developed the calcium oxide Al2O3 SiO2 based flux system in which I have added magnesium oxide, calcium fluoride, or nickel oxide, magnesium oxide, iron chrome, because my problem is already because depicted at this particular slides, because that particular area is, belongs to the chemistry, to the chemical department. So that at the time I thought, okay, this area is belong to the chemical department and chemistry. So definitely I have to discuss with the chemistry people. So at that time I discussed with the chemistry people, and I asked them how much the magnesium oxide I have to add into the main basic flux. So they helped me a lot, and it was the reasons I have developed the 32 flux, not only one flux. I have developed 32 flux, and I have designed the experiments on the basis of response surface methodology. It means it is an interdisciplinary research because I have taken the help from chemistry, from chemical department, and I have used the response surface methodology for the optimization. Because in the earlier stage, what we were doing, we were done the experiments on the hit and trial method, but it was not the right approach. Now we have different optimization tools. Whatever we are doing, whatever we have done, definitely we have to optimize it. Whatever we have chosen, were these experiments were right or wrong, not wrong, maybe right. And whatever we have taken the outputs, the strength wise, elongation wise, and whatever we have taken, it means that part we can check with the optimization tools. So that part was there. And one more point, because if you have to mix the flux and these constitutions together, so definitely you need some experiments, some equipments. Definitely there were the advantage. At my college, in the previous college, I have just taken the help from the chemical engineering department. I have mixed in these constituents in the ball miller. That part was there, and these were the different fluxes which we have created and formed. And ultimately, finally, if you have developed something, so definitely I have to check these fluxes are working properly or not properly. It means I have checked their flowability, grain size, bulk density, viscosity. So these are the different actually properties I have checked in the pharmacy department. I have checked these properties in the chemical engineering department, and I have just poured these flux into the funnel. And if these flux goes into the bottom area, flowability is proper or not, that part we have to check properly. So ultimately, we have checked in the pharmacy department, and we have checked one more properties, that is the
we left 5 minutes in the session, then we have to rejoin again.
No problem. I'll finish my talk within 5 minutes. So I've checked the bulk density in pharmacy department, and I've checked the viscosity, and by this particular viscosity meter. And finally, if I've settled down, okay, whatever we have created, whatever we have developed the fluxes, so definitely I've checked these fluxes on the mild steel plate. And finally, I've checked the strength, and I've drawn their response with the constituents, their strength, and their elongations. That part I've checked with the help of response surface methodology. And one more data I have taken from one gentleman, from one researcher. He has used ANN and describe the use of ANN in the medical, and finally detect the breast cancers and properly. So by describing these example, or by describing these the technology, I will conclude to say one thing at this particular point, because if you are in isolations, you cannot reach on the goal. You can reach on the proper goal, proper mission, by taking help from others, from different areas, from different researchers. So that in that case, you can develop something new. Because now in these days, what is happening, there are so many maybe the product and the research developed in the area of agriculture. But if you see, okay, I'm an agriculture engineer, I can develop something in different way, or maybe in isolation, that part you can't develop. You can develop if you are involved in a group, if you take help from others. So definitely that part and the product which you are developing, it will be good and it will be useful for the society, and you can give something to the society. What is happening, because some researchers, they have published many papers, but that research not converting the input into the final reality, that is the final conclusion of the for giving the insight on the interdisciplinary research areas. With these words, I would like to thank each and everyone, and I feel it will be grand success, and credit goes to Dr. R.C. Singh, Dr. Rajendra, Dr. Rohit ji. Thank you very much.
Thank you, Professor. And Dr. Ajay has said it very well that only the publication will not solve the purpose. In interdisciplinary, if you are getting the publications, good research, it has to be converted into a meaningful research when it is contributing to the society by developing good things. So